In this lesson, we will learn how to simplify square roots. Now, to set this up, imagine that you are solving a question involving square roots and you come to the conclusion that x is equal to the square root of 25. As you can imagine, when you check the answer choices, the solution x equals the square root of 25 is not one of the solutions. The reason for this is that we can simplify the square root of 25 to get x equals 5. This is no different from taking a fraction like 7/14 and simplifying it to get 1/2. Now, what do we do with a square root like this? Well, even though there is no nice integer equivalent of the square root of 20, we can still simplify this as 2 times the square root of 5. In this lesson, we will learn how to perform these kinds of simplifications. To do this, we must first study perfect squares. Now, these numbers are called squares, or perfect squares, because they are the squares of integers. 4 is equal to 2 squared, 9 is equal to 3 squared, 16 is equal to 4 squared, and so on. Now, the great thing about perfect squares is that when we find the square root of perfect squares, the result is an integer. So, for example, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, and so on. Let's take these perfect squares and write them up here. Now, here's how we can use perfect squares to simplify square roots such as this one. Notice that we can take 20 here and rewrite it as 4 times 5. Now, the important point here is that we have rewritten 20 as the product of 4, a perfect square, and 5. At this point, we can apply the following property to rewrite this root as the product of 2 roots. Now, the square root of 4 is equal to 2, and the square root of 5 has no integer value, so we will leave this as it is. So the square root of 20 is equal to 2 times the square root of 5, which we can rewrite as 2 root 5. Alright, let's try another one. Our goal here is to take 54 and rewrite it as something times something else, where one of those somethings is a perfect square. How can we do this? Well, we can rewrite 54 as 9 times 6, where 9 is a perfect square. From here, we can apply the following property to rewrite the root as the square root of 9 times the square root of 6. Now, the square root of 9 is 3, and the square root of 6 has no integer value, so we will leave this as it is. So the square root of 54 is equal to 3 times the square root of 6, or simply 3 root 6. What about the square root of 35? Can we take 35 here and rewrite it as the product of 2 numbers where one of the numbers is a perfect square? Well, the answer is no, so we cannot simplify this root any further. Now, when it comes to simplifying roots, we can save a lot of time by finding the largest perfect square that divides into a number. In this example, we might recognize that we can rewrite 72 as 9 times 8, and then apply this property to rewrite the root as the square root of 9 times the square root of 8. The square root of 9 is 3, so we can simplify the square root of 72 as 3 root 8. The problem here is that we have not completely simplified the square root of 72. This is analogous to taking the fraction 12/18 and simplifying it by dividing top and bottom by 2 to get 6/9. At this point, we still haven't completely simplified the fraction, since we can still divide top and bottom by 3 to get 2/3. So with this example, we can still simplify the square root of 8. We can take 8 and rewrite it as 4 times 2, and from here we can rewrite this as the square root of 4 times the square root of 2. The square root of 4 equals 2, and we can simplify all of this to get 6 root 2. Now, we could have saved ourselves a lot of time if we had looked for the largest perfect square that divides into 72. Since 36 divides into 72, we can rewrite 72 as 36 times 2. When we apply this property, we get the square root of 36 times the square root of 2, which simplifies to be 6 root 2. Now, sometimes it may be difficult to take a number and rewrite it as a product where one number is a perfect square. For example, how would we rewrite 756? Well, in these instances, another strategy is to first rewrite the number as the product of primes. Now, if you don't already know how to do this, you might want to learn how in the integer properties module. Once we have rewritten the number as the product of prime numbers, we can group the prime numbers in identical pairs. So we can take these two 2's and treat them separately, and similarly we can treat these two 3's separately. At this point we have no identical pairs remaining, so we will treat this remaining product separately as well. Now why did we do this? Well, notice that 2 times 2 here is 4, 3 times 3 is 9, and 3 times 7 is 21. Now the square root of 4 is equal to 2, the square root of 9 is equal to 3, and the square root of 21 we will leave as it is since there is no nice integer value for this. When we combine these terms, we can see that the square root of 756 is equal to 6 root 21. Okay, let's summarize the primary technique for simplifying square roots using this example. Our first task is to rewrite the number as the product of a perfect square and some other number. So here we can rewrite 700 as 100 times 7. Next, we rewrite the root as the product of two roots as follows. Finally, we simplify the root of the perfect square. In this example, the square root of 100 is 10, and the square root of 7 cannot be simplified, so we leave that as it is.